All right, class, today we're going to be solving equations involving radicals. There are three different types of equations that can have radicals in them. We can have radicals included in a power, meaning that I have like a fractional exponent, like 1/2 or 1/3 or something like that. Or I could have an equation with a square root or a cubed root or a fourth root. Or I could actually have more than one radical in the same equation. Whenever I'm solving an equation with a power, the first thing I want to do is isolate the power, isolate the variable. So I have x to the fifth equals 1024. And then I have to do the opposite of the fifth power, which would be the fifth root. Since 5 is an odd number, I do not need to include plus or minus. The fifth root of 1024 is just 4. And that would be my solution. Again, we always want to do the opposite of the power. Quick review about fractional exponents. Whatever number is in the bottom represents a root. So technically this is saying the square root of x plus 3 raised to the fifth power. But to isolate the x plus 3, all you have to do is take the opposite power. So I'm going to take both sides of the equation to the 2/5 power. Over here, when I have a power to a power, the powers cancel. Or we multiply the powers. In this case, they cancel. And I'm left with x plus 3 equals 32 to the 2/5 power. So this is saying take the fifth root of 32 and then square it. Well, the fifth root of 32 is just 2. So I have 2 squared, which is 4. So x equals 1. Whenever I have an equation with a radical in it, I have to be aware of extraneous solutions. Just like absolute values, radicals can't be equal to a negative number, because that gives me an imaginary number. So if I'm ever in a situation where I have a radical number equal to -1, that's not possible. So I would not have a solution for that situation. In this case, I know I won't have any extraneous solutions because as I isolate the square root, I'm equal to a positive number. So I want to do the opposite of square rooting, which would be squaring. And I'll add 2 to both sides, so x equals 27. Now for a slightly more complicated problem, I have x plus 1 equals 7x plus 15, all square rooted. So again, I'm going to have to check for extraneous solutions. So I'm going to square both sides. The square and the square root cancel each other out on the right-hand side. And on the left, x plus 1 quantity squared means x plus 1 times x plus 1, which means that I'm going to have to distribute. So I have x squared plus x plus 1 equals 7x plus 15. And I will go ahead and combine like terms. Since I have an x squared and an x in the same equation, I need to either solve by factoring or the quadratic formula. So I have to equal to 0. I have x squared minus 5x minus 14 equals 0. want to see if I can factor this first, because that's often faster than using the quadratic formula. Factors of 14 that when I add them up, I get negative 5. So that would be negative 7 and positive 2. Since the leading coefficient is 1, this factors very quickly. Then I will set each factored part equal to 0, x minus 7 equals 0, and x plus 2 equals 0. So x equals 7 and x equals negative 2. Now these represent my solutions that I need to check to make sure that my radical is not going to be equal to a negative number at any place. I'm going to go back up to the top, and I'm going to focus on 7 first. So if I plug in 7 in here, 7 plus 1 is 8. So my radical is equal to a positive number, so that's a good solution. For the second solution, negative 2, if I plug in negative 2 into just this side of the equation, I end up with a negative 1. Well, in no way, shape, or form will a square root be equal to a negative number. So that means that x equals negative 2 represents an extraneous solution, and there is only one solution to this problem. We'll talk about this further in class. I want you to have a good base for it for our discussion.